they want to. Good evening, everyone. My name is Konstantin Budnik. I'm co-founder and the CEO of the company called Memcore, which no one of you have heard of because we're very new and very small. But anyway, so I'd like to actually express my gratitude to GridGain for having us here and then hosting this awesome meetup. So, and of course I will be talking about the Apache Ignite. So unlike Nikita and Dima, my dear friends, I will be talking about Apache Ignite not from the perspective of how you can do this on your laptop, but I'm going to talk about this from the perspective how you can do this in the real setup, right, in real life, on the real cluster, okay? So, but first of all, so about myself a little bit. So I've been doing a lot of open source work in my life. I'm the member of Apache Linux Foundation, been mentoring a bunch of the projects in the Apache and helping them to move forward. And Apache Ignite was one of them. I helped them to become the top-level project back in the day. In general, I'm doing distributed computing, JVMs, whatever it is. And recently we started this company called Memcore, which is providing the self-services in-memory solutions for cloud and premises, right? So we'll see in a second what I mean by that. Anyway, so you all been seeing this the demo that Dima was doing, Dmitry was doing, and one of the actually kind of culprits with that thing is you trying to deploy something, right? And you're trying to deploy something in the environment which could be changing a lot, right? So for instance, the permissions on the folder that data is supposed to be in is not right? So your Spark cannot read it, or your Ignite cannot read it. Or your cluster node, firewall blocks some traffic on certain ports and whatever, right? So, and your cluster doesn't work because of that. So, and you're trying to come to the repeatable way of deploying a complex distributed system, and actually you cannot do this without proper tools, without preservation of the state, without an ability to deploy the cluster in a idempotent fashion, right? So that's why I want to talk a little bit about the BigTop. Apache BigTop is essentially the framework which allows you to do these things and more. And I'll be quick, don't worry about this, we'll get to Apache Ignite in a second. So first of all, Apache BigTop is essentially providing the Apache big data processing stack that is readily available for deployment. It has tools for development of the stack and development of the artifacts, integration testing and deployment of the stack, as well as the configuration management, right? So that's exactly what I was talking about when I said you need to have a predictable way of rolling out your distributed system into the production or into the test environment or whatever. So you cannot just copy the jugs around, right? So basically back in the day, people would say like, hey, it works on my laptop, so I don't care if it doesn't work on yours, probably your laptop is good or something like that. So it doesn't work this way anymore when you deal with like hundreds of thousand nodes in your data centers, right? So it's hard to actually deal with them if they are all unique. Anyway, and BigTop was there for whatever 4 or 5 years in Apache, and essentially every single Hadoop distribution in the world right now is built using this framework, right? So you go to like Hortonworks or MapR or whatever, so you'll see how they're using it for production of their Linux packages and the like, right? So, and lately, BigTop, and again, in major part because of the Apache Ignite, came to the spotlight. So BigTop has started moving more and more towards the in-memory, right? So in-memory computing rather than traditional batch-oriented kind of stuff that Hadoop is infamous for. So what allowed us actually to start shifting towards the in-memory computing without abandoning people who actually still married to the Hadoop stuff is a couple of the unique components that Ignite provides, and namely this is the legacy HDFS MapReduce kind of acceleration layer, right? So you can grab your MapReduce, run it on top of the ignited memory MapReduce engine, get yourself like 30x performance without changing the code, without changing anything, right? Shared state, as Dmitry mentioned, is a big deal because you actually can ingest the data in one process and then transform or load the data into another process, right? So you can actually fully have a distributed ETL processing in the cluster if you need. So, and the idea behind this is pretty simple. So you're using the RAM of the cluster as the storage media, right? So you have more RAM, you can stuff more data in it. And if data doesn't fit the memory, then Ignite will, gracefully start flooding it into the tiered, storages like off-heap storage, then swap, and so on and so forth. So anyway, you've seen this picture, so this is great. So what you do with this in real life? So you start connecting. So this is your memory core essentially, right? So you have this in-memory distributed operating system, right? So you have all these nice services that are inside of it. So what you can do with it, right? So you start connecting naturally the applications to work with the memory, right? So you start connecting things like MapReduce and Hive to Hadoop Accelerator layer, right? So you start connecting like Storm, Kafka, Flume, whatever you name it, to the stream part of the Ignite cluster. You start doing stuff like HBase and Spark, connecting it into the data grid to work directly with the data structure stored in memory, and so on and so forth. So at some point you get yourself this nice, ugly picture where every single layer, or more or less every single layer of your memory computing system is actually connected to the external third-party applications that do a variety of things with the data, right? So like machine learning, like real-time processing like HBase does, or batch processing like Hive does, or some crazy stuff has been written 10 years ago in MapReduce, whatever it is, right? So you can actually essentially all be connected to the same memory bus and get the performance benefit itself, right? So instead of, like, if you think about this, every single piece in this picture, instead of going into secondary storage in order to leave something behind for the next guy to pick up, so you just process it in memory and leave it in memory, and the next guy pick it up from memory. So you save yourself like round trip to disk, which in case of HDFS could be painfully slow, and in case of local disk could be painfully not distributed, right? So that's the options you have. So anyway, and getting back to BigTop, BigTop allows you to actually get all this nice stuff all together in predictable fashion, roll it out into the cluster, and essentially try exactly what you're trying to, or what you're attempting to deploy into production. So you have your test environment, you deploy your cluster, you run all your tests, whatever it is, then you deploy exactly the same set of tools, set of the packages, set of the configurations, module production versus test, right? And deploy it in the production cluster, and here we go, you got yourself a tested system, right? So everything's fine. So this is essentially the difference between like rational approach to software development versus empirical approach to software development, right? So you probably can rationalize around a quick sort algorithm and then see it and write it perfectly without any bugs in the first sip. But once you start dealing with the system that has to work on a 1,000-node cluster, you probably cannot rationalize everything. You have to actually try this thing. You have to make sure that your code works properly. I remember the story actually back from times at Yahoo, when the guy who was at the HDFS team, he was trying to actually beat the world record in what was it, number E calculation, I guess, or pi calculation, maybe something like that. Yeah, probably it was E calculation. But anyway, so he ran this crazy MapReduce job in a 500-node cluster, and it was actually crunching the stuff and crunching the stuff and crunching the stuff and getting to whatever the 2,600,005 digital number after the dot, after the period. And essentially, what happened? The computers in the data center, this particular set of records of computers, they had some bug in the firmware that was controlling the PSU temperature, right? So the guy actually melted the racks of the computers running the MapReduce job, right? So that's an interesting story. So that was perfect bake-in of the software, I guess. But anyway, so what I'm trying to say here is that when you do something in the real life, don't assume environment, always control environment, right? So use the right tools to control the environment. And that's essentially what TikTok does. And this is one step to rule them all, actually. So now we get into the fun part. So hopefully you're gonna, all of you are gonna have a lot of laughs about this. So what I'm going to do, I'm going to actually really deploy the cluster right now in front of you into the AWS. So what I'm going to do here is, so this is actually the tool. It's a piece of Memcore platform. So we do this deployment quickly and painlessly, and every single time is the same. But as with any live demo, things might happen. So bear with me if we crash. Hopefully we're not. So in about 80 seconds, we should have ready to go to cluster. And the cluster is actually preloaded. I cheated a little bit. So the cluster is preloaded with about 2 gigs, actually 1.6, something like that, data from GitHub archive. So GitHub archive actually logs all the events happening on GitHub, right? So you fork something, it logged. You know, submit the pull request, it logged. Yada yada yada. So we essentially got like a week worth of the data from the GitHub archive, right? So put it on HDFS in the cluster that I'm spinning up right now. And then what I'm going to do, I'm going to show you the ETL processing with all these, you know, glorious tools you hear so much about, right? So Apache Spark and Apache Ignite and Apache Hadoop and HDFS and what's not. So and SQL, of course. So initially, I think I wanted to go with a simple MapReduce demo, but you know, MapReduce is not sexy, right? It's not fun. So it's like boring MapReduce JavaScript. So here's a couple of links for you. So if you want to actually really, you know, watch the MapReduce porn, there is the video on YouTube. It's about like 5 minutes. It goes through all the stages of the cluster deployment, what's not, how to run the stuff. And the second link is actually the script, the instruction, right? You can follow and do this yourself at home, right? So it's not one of those things that you're not supposed to do at home, but one of those things that you do supposed to do at home. And basically at the end of this exercise, you can show how in-memory MapReduce actually beats the legacy MapReduce by about 30 times. Performance-wise, without changes in the code, right? So it's pretty magic. But then I thought, like, okay, so MapReduce is not fun, so let's do something really cool. So, and we are going to do this cool stuff. Oh, okay. I guess my cluster is up and running. Don't read too much in this either. I have too old of Ruby on my system. Okay. Here we go. So let me quickly see if the cluster is up. It should be up. There we go. Good enough. It's real up. So now what I'm going to do is, let's see, these nodes. So because it's a fresh cluster, I need to actually grab this host name here, so I can connect to it. And okay, so that's a cluster. And Hadoop is there, I guess. Yeah. Okay, anyway, so, and here, what I'm going to do is this. So check it out. So there's some old trash, the old states, whatever. So the dead nodes are actually shown still. But anyway, so we have 4 workers for Spark, and surprise, we have the Zeppelin instance running there as well. So we actually can run some cool queries and all. Anyway, so I even have the remote. Okay, cool. So, right. So what I'm going to do is essentially I'm going to do the extraction, right? So I'm going to read the data from HDFS into the cluster. Then I'm going to flatten the structure because it's actually a bunch of the JSON which has like 4 levels of enclosures of structures and structures in the structure, right? So it's sort of kind of crazy to work with this stuff. So I'm going to flatten it, and then I will load the data into RAM, right? So after that, I actually will kill the client or kill the session, which will do all this kind of extraction, transformation, and the load, and we'll move to a totally different client, right? And run the SQL queries on top of the data which already sitting in the cluster. So it's actually like how to preserve the state between two different jobs, essentially, right? So, okay, let's see if I can make it work. I have a little cheat sheet, of course, so I don't need to type everything and worry to death. So what I'm going to do, I'm running a Spark shell here, right? So, and in the Spark shell, whatever, doesn't matter. So in the Spark shell, I will essentially do a couple of things. So first of all, I will read a bunch of data, right? So second of all, I will flatten the data. So I will get the data into the RDD, right? Then I will flatten the data. And after that, I will run the loading process using Apache Ignite to get the data into Ignite cluster memory, right? So as I said, there is a 5 nodes cluster. It's about 10 gigs of distributed memory in it. So I'm loading about 2 gigs, whatever, right? So I don't care. But anyway, at this point, I will quit the shell and we'll move into something more fun. Okay, so let's extract it, right? So and that's fairly straightforward. I'm just running a SQL context read. And it's going to take a little bit of time. As I said, there's about 2 gigs of, or a little bit less of data. And essentially, Spark is doing a great job parsing the JSON out of the gzip files. Actually, it's not the Spark, it's a blueprint performance. But anyway, so Spark is cleverly using it. And we are about to be done in another couple of seconds. AWS is actually pretty fast. What exactly this? Of course, right. So this is me. I forgot the imports, right? So because we're sitting in Spark and we need to actually load some extra stuff, some extra memories. Just a second. Okay, so now what I'm doing here is actually I'm setting the client mode. I am registering the cache, or not registering the cache, but rather actually declaring the cache name. So and now I'm doing the transform. This is actually this RDD operation, right? So I'm calling the map on RDD in order to flatten the hierarchical JSON structure into flat map, right? So, and the reason I'm doing this is because it's easier to work with the data like that, right? So, and we're good, all flattened. So now let's load it, right? So, and the way I'm loading this is essentially I'm, as Dmitry mentioned, Ignite has this shared RDD notion, right? So this is essentially the RDD which is immutable and can be indexed, right? So what I'm doing is that I'm loading the data from Spark job into the Ignite shared RDD, right? So and that would take a few seconds, I guess. So essentially, the most interesting command here is that save pairs. Right? That's actually where the storing part happens. So
is that lazy or is that immediate operation?
As you can see, it's pretty immediate operation.
It's a lazy operation, so sometimes it's harder to store what you want as easy.
So
an action occurs rather than
right, the shared RDD is essentially the same RDD. It supports everything that is there in Spark, right? So it could be lazy, it could be not lazy. But in this particular case, I'm actually doing the safe pair call. It's not lazy operation, right? So I actually physically copy the data from one RDD to another, right? Okay, so and it's done actually. It's pretty fast, faster than it used to be at my last test. Okay, so at this point, I don't care, right? So I'm killing the Spark shell, and come on, yeah, okay, whatever. So done. So at this point, I'm confident that my data is actually safe. My data is sitting in the cluster, and the Ignite actually did a decent job of allocating the data among the nodes, and rebalancing it properly and doing whatever it's supposed to do according to my configuration, right? So it's all good. So what I'm going to do now is I'm going to Zeppelin, and again, because Spark does not share state, I would have to do this data frame creation one more time, but it's pretty fast actually, so it's not going to take much time. But now I'm going to take I'm going to have the data frame on the client side, so actually I can query against the data frame, right? And in case of Ignite, actually I don't need to do this because Zeppelin runs the client Ignite node. I can actually directly work with the cluster, right? So it's running. Let's see what's going on. Let's see what's going on. Yay. Whoa. Actually reminds me of the story while we're doing this. At last Apache Con in Budapest. So the guys from Zeppelin, they were showing, doing a bunch of the presentations, right? They're showing the UI, showing how it can work with Hive and Spark and what's not. And at some point, somebody in the audience said, like, excuse me, is this the open source of the Databricks Spark UI? So next presentation from Zeppelin, somebody else actually kind of overheard the joke and repeated it, right? So by the end of the day 3, every single time somebody was doing the presentation about like Spark or Zeppelin or machine learning or whatever, some smartest in the audience would absolutely raise the hand and say like, hey, by the way, I heard that the Zeppelin is the open source version of Databricks UI. So I think Spark people weren't very happy. So, but yeah. Okay. So what's going on? Okay, so we're good. So everything is there. It's actually reloaded the data again in the data frame, and actually to show you that I'm not kidding you. Anyone can read this? Probably not. A little bit better, no?
It's better.
Okay, I probably need to go back to the smaller font so no one has the idea. So I ran DF count, and again, as has been mentioned by Dmitry here, so RDD are not are immutable, right? So you cannot really build the effective cache index on it. So the funny part is that right now I have like what 2.5 million records in there. If I run the same thing again, so it's going to take exactly the same amount of time again because it needs to do the full scan again and again and again, right? So it's boring like hell. Well, hell's not boring probably, but there. So anyway, so what? Okay, yeah, same result predictably in the same slow pace.
If you did the F cache before, it would be faster.
Sorry, what?
If you do cache before the count, it should be faster.
Yeah, true, but I don't want to.
Okay.
Why should I bother with doing something extra, right? So it's data frame, I'm working with data frame. Anyway, so that's all fine. So let's do the select or the query. So the query I'm doing is essentially pretty straightforward, right? So we're going through the bunch of the data, right? So we have, as I said, about a week of data. But for all practical purposes, we will be looking for the most active repos in terms of forking just inside of one day, right? So we're going to have some between, we're going to have some where, we're going to have some wherever order buys, yada, 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 right? So it's not like the most complex query in the world, but it's actually a pretty practical query, right? So I want to see what were the most active forks on January 2nd this year, right? In 24 hours, okay? So, and I'm going to run it. And again, this is Spark, right? And yeah, okay. So predictably, interestingly enough, so Dmitry was running his query on a single node Spark cluster, right? And he got like what, 21 seconds?
21, yeah.
So I'm running a little bit different query on the 5 nodes cluster, and as far as I remember, it's going to be, oh, it's actually 12 seconds. Oh, okay, so last time I ran it, it was 20 seconds, and I was thinking like if any query in Spark actually takes 20 seconds, always. But anyway.
Start code.
Yeah, exactly, right? So, and again, yeah, so this is nice Zeppelin, so you can do things with that, right? So you can, actually it's right here. So you do stuff like this, and because again, I blow up the font a little bit, it's ugly, but in reality, actually, it's pretty nice like this, right? Well, now you can read this, but it's nice. So anyway, so 12 seconds, right? And for the, thank you very much. It gave me a break, actually. So here, so let's see if we can do.
Which project is most active?
Huh?
Who is most active? I'm just curious.
Who's more what?
Most active forks on.
What was the answer?
What is the answer to the query?
Oh, what was the answer? Most active. Let's see who was the most active. I have no idea what is that. And considering that this is PHP, it's probably like. Anyway, sorry if anyone writes PHP here, so I didn't try to attempt. Essentially, I'm going to run the same query here. Woo! Awesome. Records. Looks like my configuration is wrong somewhere. Of course, yeah. So that's my fault. Sorry about that. Actually, this is a little bit of beef I have with Ignite GDBC driver, right? You always have to specify the goddamn cache name, which means that you always have to configure the GDBC client if you need to work with different cache. I guess it's solvable. Nobody was.
Duly noted.
So what?
Duly noted.
Yeah, but anyway, so now I have the GDBC because Zeppelin works with Ignite cluster through GDBC client, right? So you have to actually do this. So I restarted the interpreter. Everything should work now, actually. Whoa! See how fast is that? No need to rescan anything. Let's run it again. Oh my god, even faster. Oh wow. Okay, that's pretty cool. Anyway, so. And now I'm actually going to run exactly the same query that I did last time in Spark, but this time I'm going to run it in Ignite, right? And it's actually exactly the same query, so I can blow up the font a little bit, so same, I'm not kidding you. So let's run it. Woo! Oh my god. I don't even see the time. Yeah, it says 0 seconds. So in reality, actually, if you run this stuff in something a little bit more down to the earth, like again the Spark shell or something like that, you would see the detailed report of how much time actually the job takes. So in my experiments and the experiments of my colleagues here, so we've seen the best we've seen about 100 times actually. So like 45 seconds on Spark and literally about 70, 60 milliseconds on Ignite. So it's like, holy crap. Anyway, so that essentially concludes my awesome presentation and leads to the next section of this evening, question and answer. You can ask me anything. I mean, anything.
So I'm going to ask the same question I asked.
I knew you were going to ask this question. Yes.
I can ask a different question if you want a new one.
No, please go ahead. I don't have an answer anyway, so I didn't have it the first time.
Now, I'm interested in seeing performance comparisons against commercial products, because one of the things that we've noticed with the open source community and the Apache community, they all publish performance results measured against each other. None of them have published an audited, certified industry standard benchmark
Great.
that would allow people to compare performance against Oracle, against SQL Server, against
Yeah.
VectorWise, against Paracel. So I really don't know what these numbers mean.
Okay, I actually can perfectly answer the question. Now I see where you're going. So, how many of you guys here contributing to Apache or like Apache committers or contributors? Oh, come on, just 5, 6 people? Oh my god. Anyway, so I'll tell you, I will get to your question in a second. I will tell you really quick how Apache works, right? So Apache is actually building the software for the public consumption, right? So we build the software, people who are volunteers, right? So who are not getting paid by Apache Foundation, sometimes they're getting paid by their employers, whatever it is, right? But they contribute in their time into Apache Foundation to develop the software that people can use, right? And awesome things coming out of it, Apache Web Server, Apache Tomcat, Apache, I wouldn't say HDFS, although I like HDFS, but it's not that awesome. But anyway, so Apache has about 300 projects actually under its umbrella, right? And the reason actually it's so prolific and so effective in what it is doing is because Apache doesn't care about performance numbers. Right? Apache cares about how much fun people who actually developing the software have while they're doing this, right? So in this respect, you probably never will find an official Apache numbers of how much memSQL faster than Terracotta or something else.
Numbers. There are plenty of for-profit companies that are involved in Apache and that support Apache. We have Cloudera, we have Hortonworks, we have MapR, we have Platfora, and you know the list.
Absolutely.
Now, I find it really bizarre that all these people are talking about how great their performance is compared to some other open source project. And I don't believe for a moment that Cloudera or Hortonworks or MapR or Platfora could not greatly benefit from publishing performance results that would show that.
Yeah, but you know why they don't publish the performance results, right? Because all these talks are marketing bullshit, right? So.
I disagree.
You disagree?
Absolutely.
Okay, then you probably need to dig in and publish some numbers and share it with us, and we would be all happy and learn something new. And this is how Apache works, actually. You come, you dig, you share.
Wait a moment, you're taking the discussion to Apache, and I understand that part.
Sir, the reason I'm taking actually this discussion elsewhere, because I'm not interested in discussing actually commercial vendors who do publish or do not publish the performance numbers. I'm not working for Hortonworks, I'm not working for Cloudera, I'm not working for anyone else. I'm an Apache member, I'm actually representing Apache, right? And as Apache member, I'm saying, I don't care if project X is faster than project Y. All I care is that the people who work on project X actually want to spend their time on project X, and people who work on project Y want to spend time on project Y. If they want to compete and participate in the PN context, they can do this, or they cannot.
Sure,
it's their business, right?
At the end of the day, the proof of the pudding is in the eating.
Absolutely.
And we need to see, just to advance the cause that you mentioned, we need to see wide market adoption of these technologies.
Yes, when you say we, you refer to whom exactly?
People who pay money to run.
Yes, please. Sorry, there's another question.
One of the big problems with performance numbers is performance is so context sensitive. It's what's the network, the hardware, etc. And so the paradigm that we've been looking at is, this is true in the virtual world, is that the way we're doing performance is relative. So we spin up two different technologies on the exact same infrastructure, the exact same node, and the only thing you can really conclude is kind of the ordinal relationship, not the cardinal relationship. So I think that is how I would do performance tests, not actually do numbers, but doing side-by-side tests.
The industry has answered this problem.
Gentlemen, if you can excuse me, I'd like to interrupt you here, and if you actually want to take the performance discussion to the deeper level, I suggest you do this offline, because there's another 50 people here who might want to discuss something else. Anyway, so other than performance questions. Okay, no. Anyway, so thank you very much for coming in and learning how we actually deploy stacks and work with the stacks. Thank you.